Hello and welcome to the Concept 33 Notes for Geometry, the final concept notes for Unit 8. Today we're going to do trig applications. So we're going to focus on word problems and the words terminology, angle of depression and angle of elevation. Take a second and pause to fill in the vocab here. So an angle of elevation is the angle between the horizontal and the observer's eye going upward. So if you look at this diagram, the angle of elevation is here. We're going up from the horizontal. Where the angle of depression is the angle between the horizontal and the observer's eye going downward. Here I have here. Now, because two horizontal lines are parallel, the angle of depression and the angle of elevation will always be congruent. So if you know one, you know the other. So let's look at some examples. In our first example, we're going to talk about the Daytona International Speedway, which has a racing surface width of 40 feet. The angle of elevation of the track in the turns is 31 degrees. And we want to know how tall each corner is. And it says round to the nearest foot. So in all our examples, we're going to work with a right triangle. I'm going to go ahead and draw my right triangle. The angle of elevation down here is 31 degrees. Now, you want to think about this problem. Our triangle is representing looking at the track and seeing the bottom left is like where the track is starting, and this top right up here is where it's going to be like near the stands. So our hypotenuse is actually the width of our track, because that is the distance between the track closest to the middle and the track closest to the stands. We want to find how tall each corner is, so we want to find that height difference between the inner part and the outer part. Now that we have our triangle drawn, we can figure out our trigonometric function. In this problem, our angle is down here, x is the opposite, and 40 is the hypotenuse. When we use the opposite in hypotenuse, we're going to set it up with sine. So sine of 31 equals our opposite x over our hypotenuse 40. We are going to multiply both sides by 40 so that x equals 40 sine of 31. Go ahead and put that in your calculator. We're going to round the answer to the nearest foot, and you should be getting that the width is 21 feet. So now, moving to our next problem, we're talking about the Kansas Speedway. We know the height of the Kansas Speedway is 16 feet in the corners, and the angle of elevation is 17 degrees. What is the width round to the nearest foot? So again, we're going to draw our right triangle. We know the height is 16 feet. The angle of elevation is 17 degrees, and I'm going to rewrite that so we can read that a little bit better. And we want to know the width. Again, the width is the hypotenuse because that's the distance from the inner part of the track to the upper part of the track. We are going to use sine again. Sine of 17 equals 16 over x. You always want to multiply both sides of your equation by the denominator. So we end up with x sine of 17 equals 16. X is still not by itself. So now divide sine 17 over so that x equals 16 over sine 17. Put that in your calculator. We want to round to the nearest foot, and you should get that x is 55 feet. Moving on, a lighthouse operator at a point 25 meters above sea level sights a boat. The angle of depression to the sighting is 10 degrees. How far is the boat from the base of the lighthouse? So I'm going to be a little bit extra here. I'm going to draw our lighthouse. So we have this lighthouse here. It's not going to be a perfect drawing, but it's going to be all right. We have this person in a lighthouse. That lighthouse is 25 meters above the sea level. Someone in our lighthouse sights a boat. So they're going to look down and they're going to see a boat out here in the water. I'm going to draw a little sailboat out here. And we're told it's an angle of depression. An angle of depression is made with the horizontal looking down. So we actually have this angle of depression 10 degrees outside of our triangle. Because the horizontal lines are parallel, my alternate interior angles are congruent. So my angle of depression is 10 degrees. Therefore, my angle of elevation is 10 degrees. And it says, how far is the boat from the base of the lighthouse? So we are going to find this distance below. From our angle in the triangle, 25 is the opposite and x is the adjacent. Using opposite and adjacent, we want to set up our problem using tangent. So tangent of our angle measure, 10, equals the opposite, 25, over the adjacent, x. Multiply both sides of our equation by x, so that x tan 10 equals 25. To get x by itself, we want to divide both sides by tangent 10. So x is 25 divided by tangent 10. Put that in your calculator. We want to round to the nearest foot. It doesn't say that, but that's what we've been doing. So let's go ahead and round to the nearest foot. And that the boat is going to be 142 meters from the base of our lighthouse. Our last problem is an independent practice problem. Take a second, pause this video, try the problem, and then come back once you have a chance to try it. I am going to go ahead and explain it because you should have already paused it and done this. A tree casts a shadow that is 21 meters long. The angle of elevation with the sun is 51 degrees. How tall is the tree? So again, I am going to draw a little bad picture of my tree here. The tree's shadow, which would be on the ground, is 21 meters long. The angle of elevation with the sun is 51 degrees. So this angle here is 51 degrees. How tall is our tree? So your picture should look roughly like this. From our angle of elevation, x is our opposite and 21 is our adjacent. So we're going to use tangent again. Tangent of 51 equals x over 21. Multiply both sides by 21. X equals 21 tangent 51. And we're on a roll with rounding to the nearest whole number. So x ends up being 26 meters. Thank you for doing our 33 notes as